Now, what is this fundamental forces? See, in any physics problem, the first thing that we need to identify to solve the problem is to identify the force that is actually involved. Some of the forces are created by man. That is, for example, if I want to make a car to move from one place to another place, I may push the car on the engine, which provides the force to the car to move from one place to another place, or any vehicle for that matter.
Sir,
But
Sarvesh also joined, sir.
okay, that's good. Uh, but there are certain forces which are already existing in, and whenever we solve a problem, in addition to the force that we apply, the man-made forces, we also will have to take into consideration these forces. So the first very important force that we have is the gravitational force. That is something that you might have studied in your 10th standard. Gravitational force, actually it was proposed by Newton, who said that if you have any two masses, if you have any two masses, the two masses are attracted towards each other. Now, the something that keeps running in our mind is that, sir, why is it that I don't feel such a thing, or it is not a palpable na measurable இல்லையே நான் நேர்ல பார்க்க முடியும். Imagine I have one car and another car. I never see two cars attracting each other. I never see two buses attracting each other. But remember, this force is existing between those two cars or those two buses. Only thing is that the force is a weak force. The force is a weak force. It's a very weak force. That is why for smaller objects, that is objects of lesser masses, then you may again ask me, sir, yes, sir, is it possible the less mass? Yes. The mass compared to that of terrestrial objects. That is, if I assume M1 to be Earth and M2 to be Moon, then the situation is completely different. And you all very well know that it's only the gravitational force which keeps the Moon attached to the Earth. And if the gravitational force had not been there, the Moon would have simply drifted away from the Earth. Right? We do not have a Moon at all. So now these are terrestrial, and their masses are tremendously high. And this force now becomes very, very significant when the mass becomes much greater. As I told you, the force is a weak force. At the same time, it's a long range force. It's a long range force. It's a long range force. This force is something that we cannot simply uh, uh, brush it under the carpet, because we very well know that there is there's a tidal, waves, sea waves. There's a tidal action taking place during full moon day and no moon day. The tidal waves behave very differently during those days. This is a very well-known fact, and this is purely because of the gravitational force. So we have to keep in mind when we are going to try to solve this problem. What is the problem that we are? Let us say, for example, I'm going to send a rocket to Mars. Then I cannot simply neglect this force and keep in mind only the force that is exerted by the fuel of the rocket, because this force is significant there. And if I don't take into account, I am not going to land my rocket exactly in Mars. I may be landing it in some place. So this is something to be taken into account. The next very important force that we have is called as your electromagnetic force. It's called as your electromagnetic force. With all honesty, I can say that you are definitely going to understand more about all these forces after the completion of your 12th standard. That is what the truth is. Because after studying all parts of physics, that is electricity, magnetism, mechanics, and all these things, only then you are actually going to appreciate what is being taught right now. But still, it is a kind of an introduction that is being given to you, and I am about to tell you about that. Now, when we talk about electromagnetic force, you have two charges. You take two charges like Q1 and Q2. These two charges, these are things that you might have studied in the 10th standard. Again, if they are like charges, for example, if this is positive and this is also positive, there is a force of repulsion happening between these two charges. And if at all, let us say if we have one is positive and another will be negative, and even that, then this force is going to be an attractive force. So this is all about charges. Later in your 11th standard, you will learn that if this charge starts moving, it produces a magnetic. It produces a kind of a magnetic field. Now imagine this magnetic field interacts with another magnetic field. That is a magnetic field produced by a magnet, north and south magnet. If it is interacting with that magnetic field, then this charge is affected by this magnetic field, thereby giving to what is called as an electromagnetic force. Am I clear? Right? So more specifically, I can say that whenever charges are accelerating, not moving, whenever charges are accelerating, they produce what is called electromagnetic waves. Produce what is called as electromagnetic waves. This is something that you are going to learn in your 12th standard. That you are going to find that, for example, the waves that are being produced by a cell phone are your electromagnetic waves. What the matter? It need not be a cell phone. It is ordinary radio waves, whether FM radio or anything that keeps producing your electromagnetic waves. How does that electromagnetic wave being produced? All that you have to do is that you have to accelerate the charge within the circuit, and it produces an electromagnetic wave, and that wave also exerts a force. So that also will have to be taken into consideration. Very interestingly, you are going to learn that light is also an electromagnetic wave. Light is also an electromagnetic wave. So this is a very, very important force to be taken into consideration when we are going to work out a problem. Right. The next very important force that is there is called as your strong nuclear force. Actually, this is bifurcated into strong nuclear force and weak nuclear force. Generally, we call it as the nuclear force. So let us try to understand. All of you know that if you have a nucleus, the components of nucleus are generally protons and neutrons. Right. Do neutrons do not have any charge? Protons are all positively charged. Have you ever imagined how is it possible that two protons, which are positively charged, can stay inside a nucleus? Right? Both of them should actually get separated and move out, and as a result of that, the nucleus should actually collapse. But that is not happening in nature. In nature, you find that the protons are put together in the same place and they stay together in the same place, which means, so very clear, if I have two protons, let us say two protons which are trying to repel each other, there should be a greater force which commands them to stay put in the nucleus, which means there should be a greater force which binds them together, which keeps them inside the nucleus. And this force is called as your nuclear force. Nuclear force is a very, very strong force. It's a very, very, very strong force. And very interestingly, I will this does not only this not only exists between proton and proton, it also exists between a proton and a neutron. It also exists between a neutron and a neutron. Now, there is something that may not be clear to you right now. How is that neutron doesn't have a charge, and how is that nuclear force exists on these neutrons? But that is how the force is. So it's a force that does not depend upon the charge. It's a very strong force, and generally it happens within the nucleus. So obviously, though it is a very strong force, it is a gravitational force. We call it as a gravitational force. We call it as a long range force. But this force, we are going to call it as a short range force. Short range force means you can imagine the size of a nucleus, and within that, imagine the distance between proton and proton and proton and neutron and neutron and neutron is very, very small. So which means that this force acts really strong. Really, it commands only at a very short range. Whereas if you take the gravitational force, it commands in the long range, but keeping in mind that it is a very, very weak force. Right? Any doubts so far? Anyone can ask me till now, so that I am confident to move on further.
Sir,
Anyone has got a question on this?
Yes, sir, I have got a question, sir. The short range was the short range only, sir, and the radius is how it is 10 to the power how many minus?
Okay, fine, sir. So nucleus, remember, has got 10 power minus 15 meters the radius. So we can talk about between a proton and a proton, somewhere between 10 power minus 17 meters. A very, very short, small range where this force is going to be affected.
Sir, what about the attraction? What is the attraction between proton and electron? Is it a nuclear force attraction or is it electrostatic attraction?
No, between proton and electron, it's a completely different case. You have to keep in mind nucleus is here.
Yes.
And your electrons are all revolving around the nucleus.
Correct.
So between proton and a neutron electron, it is a Coulomb's force.
Coulomb's.
That is, it is treating it as a positive charge and a negative charge. That is very much like an electromagnetic force. Positive charge and a negative. So that is a different force. But short range force, that is a nuclear force, acts only within the nucleus. It doesn't happen outside the nucleus.
Sir, in case of hydrogen, in case of hydrogen,
please,
one proton, sir, yeah.
ஆமா அங்க இருக்காது. அங்க வந்து ஒரு proton தான். ஒரு proton ஒரு electron தான். Nuclear force அங்க கிடையாது. But there is an existence of Coulomb's force existing between the nucleus and the.
Okay. Thank you, sir.
Okay.
நான் கேள்வி கேக்குறேன் பாருங்க.
நீங்க கேள்வி கேக்குறீங்க, பசங்க கேட்க மாட்டாங்க. That's right. Okay. So, and we have something called as the weak nuclear force அப்படின்னு இருக்கு. This is completely this is again a topic which you will understand under something called nuclear physics, which you will learn in.
Sorry to interrupt you, sir. Actually, there are only 4 types of forces existing. One is gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. Only 4 types of forces are there.
4 types of forces exist. Yes. Yeah. So this, weak. We have something called as a weak nuclear force here. This weak nuclear force, this happens in something called as beta decay. I'll tell you about what beta decay is. So this happens in something called as a beta decay, and this is the place where this nuclear force generally tends to appear. For example, you may think of a element having a mass number A and atomic number Z. When beta decay happens, it actually emits an electron. So it emits an electron. So what happens is that you get a new element. You get a new element, Z plus 1, and of course you will have an emission of electron. So this is the process in which there happens to be the influence of this weak nuclear force. But remember in my mind that weak nuclear force is not as weak as the gravitational force. That is very important. Though it is called as a weak nuclear force, don't compare it with that of a gravitational force. It is not that very weak, but at the same time, what to say? It is not as equivalent to that of the strong nuclear force. Keep in mind that it is little bit higher than that of the but it is weaker than what is called as your. It is weaker than your electromagnetic. It is weaker than your electromagnetic. So, and of course, it is also weaker than your strong nuclear force. But keep in mind that it is little bit higher than that of your gravitational force. This is something just little bit complicated. I cannot go deep into it because only when we talk about nuclear physics where this is dealt in detail about this. So here again,
this is radioactivity, sir. Radioactivity. This is what.
radioactivity la varum. And the radioactivity la varum.
Uranium will get.
Correct. அதேதான். இதெல்லாம் radioactive position தான் the beta decay என்றதே நம்ம போறோம். Alpha, beta, gamma rays being emitted. Yeah. Beta is one of them. Very good. So your range is 10 power minus 16 meters from that. The range is only, it's very closer to that of your strong nuclear force. Range on the smaller range தான், but compared to that of strong nuclear force, இதோட force activity வந்து ரொம்ப lesser ஆகுது. So these are very important. A very interesting thing that they talk about is something called unification process. Unification process. That is what these physicists are trying to do. Is that, is it possible? See, when I'm trying to solve a problem, I would like to mind about any one friend. எல்லா ஃபோர்ஸையும் எப்ப பார்த்தாலும் டீல் பண்ணிட்டே இருக்க முடியாது. So can I unify all these forces into one capsule? That is what we are actually trying to. For example, Newton was trying to unify this gravitational law and this electromagnetic law. Similarly, which was not so successful. Later on it was Maxwell who tried to combine optics with electromagnetic waves and all. So what this unification process will tend to do is that we need not keep dealing with a lot of forces when we are solving a problem, but we are thinking about an unified force. We are thinking about a unified force. Correcta சொல்லணும் அப்படின்னாக்கா, I don't know whether you have come across this thing, something called God particle.
So about 3 years back, somebody got a Nobel Prize.
Yes. Yeah. No, not Nobel Prize. It was a controversy.
Correct.
The controversy was, according to Einstein, no particle can travel faster than that of light. So the scientists, especially we have one in Austria and some place where they are trying to find out a God particle. That is God particle அப்படின்னாக்கா the atom of all forces. Atom of all forces னா எல்லா ஃபோர்ஸுக்கும் ஒரு ஆரிஜின் ஒரு ஃபோர்ஸ் இருக்கு. அப்ப அந்த ஃபோர்ஸை நம்ம பிடிச்சிட்டோம் அப்படின்னாக்கா மற்ற ஃபோர்ஸ் பத்திலாம் அதுல இருந்து கொண்டு வந்துடலாம் அப்படின்னு தான் ஐடியாவா இருக்கு. ஸோ தீஸ் பீப்புள் ஆஸ் தே வேர் டூயிங் இட், they were moving towards something called as a God particle. God பார்ட்டிகல்னா இப்ப நம்ம என்ன நினைச்சிட்டு இருக்கோம், புரோட்டான், எலக்ட்ரான் தான் பேசிக்கான பார்ட்டிகல்ஸ், அதுதான் ஆட்டமை கம்போசிட் பண்ணுது அப்படின்னு நினைச்சிட்டு இருக்கோம். இட் இஸ் நாட் சோ. There are still smaller elementary particles, and the scientists are moving towards what is the basic of them, and that they wanted to call it as a God particle. It was a bit of controversy because they found that this particle was traveling greater than that of the speed of light. And then again another article came in the newspaper saying that there was a lot of calculation errors, so it definitely didn't travel the speed of light. Also, it's still not, the final word is not being said on this God particle. So in the unification process, இதெல்லாம் வந்து physics என்ன நடந்துகிட்டு இருக்கு, where are the scientists actually moving towards? This is what this entire chapter is trying to tell you. இதுதான் இந்த lesson உடைய basics. அந்த lesson உடைய end partல we have something called as nature of physical laws. I'll try to keep it very simple. It runs into a lot of pages are being written on this. The thing is very simple. என்ன சொல்லுதுன்னா, energy is conserved. Energy is conserved. Can anyone tell me what is conservation of energy? Something that you might have studied in 10th standard. I'm just waiting. I just want to have an interaction with you. Anyone can throw a word.
Sir, students have been told by name only, they will say, sir. யாரும் சொல்ல மாட்டாங்க. கிளாஸ்ல
வெரி குட். அப்போ
கிளாஸ்ல எப்படி டீச்சர் நிக்கவே நீ சொல்லும்பாங்க பாத்தீங்களா, ஆன்லைன் கிளாஸ்னு சொல்லி தான்.
சர்வேஷ், ஸ்ரீஜய், can you tell me that? Okay, Srijay, can you tell me?
No sir,
what is this
I don't know sir, I have no idea sir.
Very
I don't
good,
know where to start.
Ambarish. Okay, Ambarish, anyone can tell me? Okay, no problem.
Saving of the energy for future use.
Okay, conservation of energy அப்படின்னா energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. It can transform from one form to another form. It can transform from, இப்போ நமக்கு ஃபேன் சுத்துற ஃபேன் வந்து மெக்கானிக்கல் எனர்ஜி, பட் உள்ள வர்றது என்னது, எலக்ட்ரிக்கல். ஸோ எலக்ட்ரிக்கல் எனர்ஜி கெட்டிங் கன்வெர்டட் டு மெக்கானிக்கல், ரைட்டா? அதே மாதிரி if I take a dynamo, it is the mechanical energy which is creating an electrical. So energy can be created from one form to another. So For example, you might have studied something called potential energy, kinetic energy.
Sir, one small question, sir.
Yeah.
Actually,
சொல்லுங்க sir.
mass itself is energy, sir.
ஆமா இருக்கு சார். மாஸ் வந்து அது ஐன்ஸ்டைன் டிஸ்கவரிக்கு அப்புறம் தான் நமக்கு வருது.
Mass
என்ன
itself
சொல்றாரு?
is
Mass has got
everything is
energy.
energy.
Mass,
Everything is energy.
yes,
Mass is a form of energy.
Mass has got energy.
Correct.
Yes, mass itself has got energy.
E is equal to
அது
mc.
அது எப்போ வருது அப்படின்னாக்கா மாஸ் ரெஸ்ட்ல இருக்கும் பொழுது எனர்ஜி இல்ல, but when it is traveling very much approximately close to the velocity of light, that's when the energy is stopped. mc square based. C being velocity of light. C being velocity of light. That's when the mass itself changes. Mass and the energy இருக்கு, அதை பத்திலாம் நம்ம பேசலாம். See, இப்போ the question comes here, sir has put it right. E equal to mc square இருக்கு சார் அப்படின்னு சொல்லும்போது, can I throw any stone with the velocity of light? ஒரு சின்ன ஸ்டோனை கூட அந்த வெலாசிட்டியில போட முடியாது. I cannot even think of sending a rocket at the speed of velocity of light. But when electrons, protons, and neutrons, they can be made to move with the velocity of, not exactly equal to the velocity of, but slightly greater than, lesser than that of the velocity of. When they are actually moving, then that is the time when they possess a lot of energy. Right. We'll come back to this. So when we have potential energy and kinetic energy, it's called as the mechanical energy. இப்போ the famous experiment will be there இல்லையா? உங்க எல்லா இடத்தையும் பார்த்திருப்பீங்க. A coin and a feather being dropped in vacuum. A coin and a feather being dropped in vacuum. அது எல்லாரும் பார்த்திருக்கிறது. You might have even had this in your. So imagine I can create vacuum in a jar and I drop a coin and a feather. I drop a coin and a feather, and both of them are going to come to the ground at the same point, same time. And both of them are going to come to the ground bottom with the same velocity. ரெண்டுத்துக்கும் சேம் வெலாசிட்டி அப்படின்னாக்கா ரெண்டுத்துக்கும் சேம் கைனடிக் எனர்ஜி. ரெண்டுத்தையும் சேம் ஹைட்ல இருந்து டிராப் பண்றோம் அப்படின்னாக்கா ரெண்டுத்துக்கும் சேம் பொட்டன்ஷியல் எனர்ஜி. அப்ப என்ன ஆகுதுன்னா ஹைட் குறைய 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 பொட்டன்ஷியல் எனர்ஜி குறையுது, கைனடிக் எனர்ஜி இன்க்ரீஸ் ஆகுது. டோட்டல் மெக்கானிக்கல்.
Sorry sir, potential energy is equal to mgh இல்லையா சார்? Mass into.
ஆமா, இது இங்க mgh. இது mgh.
So the mass changes.
இங்க kinetic energy வந்து half mv square.
Correct. So when the mass changes, will not the potential energy change?
Yeah, when height decreases, potential energy decreases. But the kinetic energy will start increasing.
Okay.
Yeah.
No, sir, the feather you are saying correct. In the vacuum, if you drop a feather, drop a solid object.
In the point, I'm talking about any one of them.
Okay.
Sorry, if I take any one of them, yeah. If I take the coin alone மட்டும் எடுத்துக்கிட்டா இதுக்கும் மாஸ் மேலேயும் கீழே சேம் தான். நமக்கு அதை பத்தி பேசலாம். ஸோ இங்க பாத்தீங்கன்னா இதோடைய பொட்டன்ஷியல் எனர்ஜி mgh இருக்கு, கைனடிக் எனர்ஜி half mv square இருக்கு. அப்ப என்ன ஆயிடுதுன்னா இந்த இடத்துல அது கைனடிக் எனர்ஜி இல்லை, அது ரெஸ்ட்ல இருக்கு. ஸோ அங்கிருந்து டிராப் பண்ணும்பொழுது as it keeps coming down, you find that the kinetic energy increases and the potential energy decreases because of the height decreases. But keep in mind, the total energy, which is potential energy plus kinetic energy, remains constant. இது நீங்க 10th standardல படிக்கிற ஒரு விஷயம் தான். Potential energy and kinetic energy is going to remain constant ஆவே. இப்போ the same thing applies even for a feather in vacuum. The same thing applies for a feather also in vacuum. இங்க maybe it's as I said, its mass is different. மாஸ் டிஃபரெண்டா இருக்கிறதால என்ன ஆயிடுதுன்னா இங்கேயும் கைனடிக் எனர்ஜி பிளஸ் பொட்டன்ஷியல் எனர்ஜி சேமா தான் இருக்கும். இங்கேயும் கைனடிக் எனர்ஜி பிளஸ் பொட்டன்ஷியல் எனர்ஜி சேமா தான் இருக்கும். இங்கேயும் மாறப்போகுது. பட் சப்போஸ் இஃப் ஐ டூ த சேம் எக்ஸ்பெரிமெண்ட் இன் த பிரசன்ஸ் ஆஃப் ஏர் அப்படின்னு இப்போ கதையே மாறிடும். தேர் இஸ் ஏர் ரெசிஸ்டன்ஸ். அப்ப ஏர் ரெசிஸ்டன்ஸ் இருக்கும் பொழுது திஸ் இஸ் வாட் யூ see in practical life. Coin coming down first, feather coming down next. Because there is more air resistance to the feather compared to that of the coin. அப்ப இங்கே மாறி போச்சு. இங்க என்ன இருக்குன்னா, in addition to these two energies, there is also some other energy that is involved. என்ன ஆகும், இந்த ஏர்ல டிராவல் பண்ணும்போது இந்த காயின் maybe some of the energy is lost as heat energy, some of the energy is lost as sound energy. நான் சொல்லும்போது சிரிப்பா இருக்கும். என்ன சார் இது, ஏர்ல நான் காயினை மேல இருந்து கீழே தொட்டு பார்த்தேன், சூடாவே இல்லையே, எங்க இது லாஸ்ட் ஹீட் எனர்ஜின்னு சொல்றீங்க அப்படின்னு கேட்கணும். If see, you all know that when a space shuttle actually enters inside the Earth, it is entering with a tremendous amount of velocity, enormous amount of velocity. A space shuttle is generally, if you have a if you have a space shuttle, for example, you know the external part of the space shuttle is pasted with something called heat tiles. Heat tiles and what? Yes, sir, in the heat tiles, when it is actually entering from space into Earth, it is actually there is a friction between the particles that are present, dust particles. Yeah, and the dust particles is the man take when it comes with such an amount of tremendous amount of velocity, it becomes red hot. It actually becomes red hot. நம்மளோட இதுல அப்போ இங்க என்ன ஆயிடுது, பொட்டன்ஷியல் எனர்ஜி கைனடிக் எனர்ஜிலாம் ஆகுது, கூட என்ன இருக்கு, ஹீட் எனர்ஜியும் இருக்கு. there is some energy being lost as heat energy. சவுண்ட் இருக்குமா சார்னா கண்டிப்பா சவுண்ட் இருக்கும். Have you thrown an object with a great amount of speed, you might have seen that it is whizzing. Bullet is whizzing சொல்றோம் இல்லையா, ஒரு புல்லட் ஷூட் பண்ணிட்டாங்க, அங்க கன்ல இருந்து சத்தம் வந்துடும். பட் உங்க காது கிட்ட போகும்போது it gives a whizzing sound. That whizzing sound is because some of the energy is now being converted as sound. என்ன ஆயிடும், நம்ம டோட்டல் எனர்ஜி எடுத்துக்கிட்டோம்னா, மெக்கானிக்கல் எனர்ஜி இல்லை, டோட்டல் எனர்ஜி எடுத்துக்கிட்டோம்னா, இப்போ என்னென்ன எனர்ஜி நம்ம கணக்குல எடுத்துக்கணும்? You have to take potential energy, kinetic energy, sound energy, heat energy. If I add up all these energies, that will be equal to the potential, the initial energy. So that's what it says. So when we if எதுக்கு இவ்வளோ விஷயம் தெரிஞ்சுக்கணும் அப்படின்னா, there is a simple saying in physics, you know, any problem, however tough it may be, if I want to solve the problem, நான் நிறைய மெத்தட்ல பண்ணலாம். நான் பண்ணும்பொழுது என்னால கடைசியில முடியல அப்படின்ற ஸ்டேட்டஸ்க்கு வரும்போது, I can simply rely on conservation of energy. I can simply rely on conservation of energy. This beauty of this one you will be learning in your third and fourth lesson. And definitely when I do that, I'm going to give you examples for that. How you are going to solve any problem for that matter. நீங்க இன்னும் நல்லா பிசிக்ஸ் படிச்சீங்கன்னாக்கா, problems in optics, problems in electricity, problems in mechanics, problems in anything, and anything that is going to come thereafter can always be solved using conservation. Conservation of energy and energy is getting converted from one form to another form. How the form convert ஆகுது, we need to know what are all the energies that are actually involved in that transformation. இப்போ நான் ஃபார் எக்ஸாம்பிள் சொன்னேன் இல்லையா, வேக்யூம்ல நடக்கும் பொழுது நம்ம ஹீட்டோ சவுண்டோ நம்ம கணக்குல எடுத்துக்கலாம். பட் when we are doing it in normal cases, that the real cases, you have to take into consideration the heat energy, the sound energy. இது எல்லாத்தையும் போட்டு நான் calculate பண்ணனா, I may get the right answer. So this is all about the first lesson. You can just simply read it. It is more of a kind of a warm up for your entire thing. Yes sir.
கொஞ்சம் இந்த வாட்டி என்ன சின்ன ப்ராப்ளம், இந்த வாட்டி சின்ன ப்ராப்ளம்னா, என்ன பசங்களும் டென்ஷன் என்ன ஸ்கூல் போல, எக்ஸாமும் நடக்கல, அதனால பாதி பேருக்கு கன்சர்வேஷன் ஆஃப் எனர்ஜி தெரிய மாட்டேங்குது. they are having a doubt. பரவாயில்லை நீங்க சொல்றீங்க. இல்ல சார், I am saying this is a situation, this time you have to put more effort to make them understand, even teach. Yes, I understand.
Yeah, I understand. Yeah. So what shall we do? You want to continue with the second lesson or we can?
Yes, I think this should be enough. Let them decide. Hey, Srijay, Sabarish, ஏதாவது டவுட் இருக்கா உங்களுக்கு? ஏதாவது क्वेश्चंस இருக்கா?
இல்ல ஏதாவது டவுட் இருக்காப்பா?
No sir.
சார் அந்த பீட்டா டிகே மட்டும் இன்னொரு வாட்டி சொல்ல முடியும்?
கண்டிப்பா. கிரேட் சபரி.
பீட்டா டிகே
யார் நிறைய கேள்வி கேக்குறாங்களோ அவங்களுக்கு நிறைய புரிஞ்சிருக்குன்னு அர்த்தம். No, just I'm Sarvesh and not to do anything, but just say கேள்வி கேட்டா நல்லது, so that everybody can understand one more.
அதாவது ஒரு எலிமெண்ட்டுக்கு என்ன இருக்கும்னா, ஒரு மாஸ் நம்பர் இருக்கும், ஒரு அட்டாமிக் நம்பர் இருக்கும். இது பேசிக் கெமிஸ்ட்ரி. அட்டாமிக் நம்பர் தான் டிசைட் பண்ணுது அது எந்த எலிமெண்ட் அப்படின்னு, இல்லையா? அட்டாமிக் நம்பர் என்னது? அட்டாமிக் நம்பர் தான்
அட்டாமிக் நம்பர்னா புரோட்டான் சொல்லுங்க சார், மாஸ் நம்பர்னா புரோட்டான் நியூட்ரான் சொல்லுங்க. அது கூட தெரியுமா தெரியல பசங்க.
இல்ல அது அட்டாமிக் நம்பர் இங்க இசட் நம்பர். அதுதான் அதான் சொன்னேன், இந்த லெசன் வந்து நியூக்ளியர் பிசிக்ஸ் வரும்போது இன்னும் ஜெனரலா நல்லா இருக்கும். அதான் சரி. இந்த அட்டாமிக் நம்பர்னு சொல்லும்போது நம்பர் ஆஃப் புரோட்டான்ஸ் இண்டிகேட் பண்ணுது அல்லது நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இண்டிகேட் பண்ணுது. சார் சொன்ன மாதிரி இந்த பீட்டா டிகேன்றது எங்க நடக்கும் அப்படின்னா, ரேடியோ ஆக்டிவ் மெட்டீரியல்ஸ். ரேடியோ ஆக்டிவ் மெட்டீரியல்ஸ் என்னது? மெட்டீரியல்ஸ் which will quickly decay, and by decaying they give out radiation. ரேடியேஷன்ல ஜெனரலா பாத்தீங்கன்னா 3 விதமான ரேடியேஷன் வரும். இதெல்லாம் நியூக்ளியர் ஆல்பா, பீட்டா அண்ட் காமா, இது 3 தான். இதுல ஒவ்வொருத்தையும் ஒரு டிகேன்னு சொல்லுவோம். ஆல்பா டிகேன்னு சொல்லுவோம், பீட்டா டிகேன்னு சொல்லுவோம், காமா. பீட்டா டிகேனா ஒன்றும் இல்லை, இசட் எலக்ட்ரான்ஸ்ல ஒரு எலக்ட்ரானை எமிட் பண்ணிடுது. if there is an emission of an electron, right? If there is an emission of an electron என்னது புது எலிமெண்டா மாறிடுது ஒரு எலக்ட்ரான். இப்போ பாத்தீங்கன்னா இது ரெண்டுத்தையும் ஆட் பண்ணீங்கன்னா உங்களுக்கு Z வந்துடும், ரைட்டா? ப்ராடக்ட்லயும் Z நம்பர் ஆஃப் எலக்ட்ரான்ஸ் இருக்கு, ரியாக்டன்ட்லயும் Z நம்பர் ஆஃப் எலக்ட்ரான்ஸ் வந்துடும் டோட்டலா, ரைட்டா? ஸோ இந்த ப்ராசஸ்ல என்ன ஆகும்னா இது ரிலீஸ் பண்ணுது இல்லையா இந்த எலக்ட்ரானை, தேர் திஸ் வீக் நியூக்ளியர் ஃபோர்ஸ் இஸ் ஆக்சுவலி இன்வால்வ். இந்த நியூக்ளியர் ஃபோர்ஸ் ரொம்ப வீக்கா இருந்ததால தான் நம்ம என்ன ஆகுது, the electron is actually being released from this beta decay. That is exactly what this beta decay part is. Weak nuclear force is not. Yeah. Any other question?